Hello and good afternoon to our masterclass in trusting LCAs at scale. Just for your information, we'll wait a bit, like 1 or 2 minutes till we reach a certain number of people, and then we'll start.
Currently 91 people or 90 people on the call. Number is rising, so 1 or 2 minutes we will start. Okay, then let's start. Welcome to the masterclass on trusting LCAs at scale. My name is Alexander. I have Sophie with me, and I let Sophie introduce herself first. Then I get to the introductions, and we start our presentation.
Yeah. Hello, my name is Sophie Kieselbach. I'm the team lead of the experts here at MakerSide, and I'm also an LCA specialist since the beginning of my career, and I'll have the honor to present today together with Alex.
Yeah, Alexander Forel, Principal Implementation Engineer at MakerSide, and I'm kind of one of the other LCA experts here in MakerSide. And yeah, together we will guide you through the presentation today. Good. Before we dive into the topic, let me basically start with introducing MakerSide a little bit. So MakerSide is a software as a service company. Our headquarters is in Stuttgart, so in Germany. We have teams in Europe and in the US. The company was founded by Neil and Fabian, industry veterans with nowadays basically plus 30 years of experience in the world of LCA and product stewardship and sustainability. We are currently 110 employees and counting, let's say, and we serve about 70 enterprise customers around the globe. And one big part of what we do is essentially LCA at scale, and that's why we are basically talking about it a little bit today. And yeah, we hope you enjoy what you see. And if you have questions, of course, please feel free to put the questions on the chat. We will since we are basically over 100 people on the call, we will only go into the Q&A after we finish the presentation. That's it. Let's go. So, first things first. So, as mentioned, we basically do LCAs at scale for a living, so to speak. And what we often get confronted with, and what let's say also our or what we basically get mirrored as an external vision on our work is that basically LCAs at scale have a lower quality or lower perceived quality than traditional LCA studies. And what we want to do today is basically explore a little bit of what that is. I will put a bold statement out now with the next slide, essentially saying that an LCA at scale is not less, or doesn't actually impose less quality, but it's actually a bit less transparent. But let me just go through that slide in a bit more detail. So what do we traditionally associate with quality in an LCA is actually an LCA is of high quality if it is reviewed. And reviewed, or a review process or a verification process in the case of an EPD, is not necessarily a process that basically tells you how good the result of your study is or how accurate it is. but it actually tells you how transparently you documented the results, which also means the process of a review is actually a process of increasing the transparency and the representativeness of a study. So what you do in a traditional LCA is you basically take a goal and scope, you collect the data accordingly, you build a model, you produce the results, and then you basically take these results, you do scenarios, Monte Carlo analysis, all sorts of additional work on top of the actual results to basically make your study more representative, or basically prove that it basically, even if you start wiggling with the numbers, the result still holds up and is more representative. An LCA scale kind of works differently. We basically do not aim to do that, right? We basically try to create, let's say, the LCAs of the entire portfolio at once. And as such, we basically try to shoot many accurate results rather than doing one average model that is being more representative, or that we try to make more representative. We basically just calculate as many models as we need to basically figure out the numbers that we have. The problem that we have in the public perception is then with documentation, right? We basically produce very detailed results. So if you basically take a model, we basically produce a small LCA for each of the components that is in the product. And it is just impossible to basically document 10,000 or 20,000 nodes in an LCA model with the same rigor than if you would basically just boil the model down to the 10 major components and do a documentation of these. So in the end, our opinion is LCAs at scale actually usually impose a higher accuracy of the results. And also, if you want to say an accurate result is somehow a result of quality, a result with a higher quality, but we lack ways of documenting the result properly, or basically we lack the right framework of documenting the results properly because the given standards basically don't allow for it. And we just take you through a comparison of a traditional LCA and an LCA at scale today, so that you basically, let's say, can follow that point that I'm trying to make right now in a bit more detail, and we then also see and try to explore ways of bridging that gap that I try to indicate with this little blue arrow here, that we basically overcome that gap of transparency that an LCA at scale allegedly has over a traditional LCA. And yeah, just how we basically deal with that in our daily business. Good. So that's then our plan for today. So first of all, we look at the traditional versus an LCA at scale, and we look at the components, let's say, from a data perspective, from a modeling and mapping perspective, and then from a documentation and verification perspective. And then we will basically talk about the bottlenecks in an LCA at scale today, which is actually the verification. And then we basically hand over, or we go into a small Q&A and are here to answer all of your questions.
Let's start with the data collection phase, as we call it in the traditional LCA. So the standard approach, as you all know, with the traditional LCA is that you define your goal, your scope, and according to that, also the data quality requirements that you have to fulfill the goal and scope of the study. Usually, you create questionnaires in Excel or similar. I mean, there are many ways to collect data, but I think you all know what we're going for. And then you very often manually have changes in those questionnaires that are created. That might be because some numbers are out of what you expected. That might be because you have unit problems. That might be because masses are not adding up, and so on and so forth. And there is a certain back and forth between the experts, the data collectors, to ensure that the data look as how it is expected. What you lose there already is the knowledge of where actually the error was. So the whole process is prone to errors. Yeah. And what we get as an output is a tendency to create averages, because sometimes specific data are not available in the way that you collect data, or sometimes sources are not known. That potential has the potential that it creates a lot of wrong numbers or like inaccurate accuracies, and it also doesn't support the user in many very often in understanding where they actually can do the improvements. Yeah. In the approach that we take to do LCAs at scale, we basically never ever try to get data that are manually converted somewhere in between. So we pull the data directly from ERP, PLM, or similar systems, and you integrate these several data sources. So the data are getting used as they are, and if you have to do corrections or changes, then you have to find ways to do that automatically, right? Otherwise, you fail to do it at scale. And you also have to transparently document that. And because you use the ERP data, you also facilitate the supplier data collection because you know where to go next if data are not looking as you want them to look. And what you get as an output is basically you have basically the data to make order or SKU specific LCAs. And it allows also the engineers to understand what of the components are impactful and where to go next, right? And because of that, you will be able to do that LCA at scale approach. So if we compare that, for traditional LCA, you usually do one LCA, or let's say one comparative LCA, or one LCA, but with some scenarios, and you document the assumptions, the methodology, the data sets used, and like everything that you know what that data quality is. And for LCA at scale, the goal is to have many as precise as possible LCAs, and the model itself already serves as documentation because you know where you got the data from, and this is how well documented. Next step, so let's say we have all the data. Next step obviously is then the modeling and the mapping to third-party databases. So what is happening there? The standard approach as is of course with variants, but let's say that's the standard approach right now, is that you after you collected the data, you manually transfer these data into an LCA software and map it to third-party data sets, databases. You do some sensitivity Monte Carlo analysis to verify the model that you're creating. And again, because it's a human-based process, it is prone to errors. What does that mean? The LCA models, if they are very simple, then they are also easy to QA. But let's say you have a very complex model, which often happens if you go into more complex processes, then it's getting harder to QA. You might have a lot of errors in number transfers. If you have many practitioners working on something, you might have an inconsistent choice of LCA data sets, and you basically have models for one product plus scenarios. Yeah? So in the LCA at scale approach, the standard approach is that you basically ingest data from the source systems, and you get an automatic transformation of these data and the mapping to the third-party LCA databases, and you automatically create a model for each product and each component. So basically you have a one-to-one mirroring of what data you get in. And because these models are automatically generated and are mapped in an automatic way, you will have a reproducible quality of results, meaning you don't need to check all over if it's done correctly and always the same, because you have an automatic approach and you will not have those variances that might happen if you have, as for example, many people working on the same model, or even worse, one person doing the first version of a model, and then after some years in a consultancy that happens, someone else is touching the model again, and then you might have differences because something was changed, right? And if you do an LCA at scale, that doesn't help, and that doesn't happen. And also, because you have modeled everything, you don't need to do scenarios because you have a variation of each product group. Because basically you have, let's say, one product group and thousands of products in this product group, so you have your variances already covered. Yeah? So if we summarize that, and if we look at the quality of the mapping of data sets, in traditional LCAs, you have a manual mapping process, and that is very much depending on the experience of the user. Yeah, so depending on who is doing that, the quality might be better or worse, right? So just deciding what data set to use for what. And again, as if another person is doing the same project for the same company, the mapping might look different, and that already will give you slightly different results depending on where you map and what you map. For LCAs at scale, you have the mapping done once for everything, and the quality throughout the model stays basically the same because you don't change something in between, right? It's basically about the mechanism of mapping and not the mapping itself. So to compare those two, in traditional LCAs, you have one model with scenarios. You have a very poor reproducibility because the same item can be mapped to different data sets. It's error prone, it's labor intense, very labor intense, and very often you have an average that is representative of the group, but not the product. And for LCAs at scale, again, it's absolutely reproducible, and errors are usually linked to the data errors that you have in the source, which is actually good because that means you can go back directly to see what you have to change in the data, and you're not trying to understand what happened throughout the whole process. So you're much more efficient, and there is no manual work included in that whole process. Next is documentation verification. Alex, I'm handing over to you again. You're mute.
Here we go. Okay, in the documentation and verification part, we kind of repeat the same story that we basically saw on the other two items. So in the traditional LCA, what you start with is a background report, right? So you basically write a large typical LCA report, and everybody who basically, of you who went through this process once, knows it's quite a tedious process. It takes quite a lot of time. And also here you can basically have just errors from transferring numbers and reviewing things, and then you basically write the report. As you write the report, you find mistakes in the model, you go back and forth, and essentially it's an iterative process. It takes a lot of time to get through the first report, get it through the review, and then let's say the problem with the traditional approach is that is all nice and fine for the first product that you do. The problem is you basically have to do the same stuff over and over again for every product that you're looking at. So you basically do the same for the second product. And what then happens is most likely you basically use your old report as a template. You basically know which top parts you need to change. Errors happen because of bad copy pastes, but in the end, you basically always have the same process over and over. It gets a bit faster, but it's still tedious and error prone because you basically just carry errors with you, or you take the template over and follow it. And the biggest problem is that a lot of the stuff that you do while writing a report is actually you do the same thing again, right? In a traditional LCA, you have this part where you do sensitivity analysis or Monte Carlo analysis or parameter variations on certain things. And although product A is very similar to product B, you just basically do the same scenario analysis, report after report after report, again and again and again. It's always like 4 or 5 hours of building that scenario, setting it up, pulling it in, and the result is always the same. In a LCA at scale, we have one problem, and that's something that I will explain in a bit more detail in the other slides, but there is no standard for documenting these. I mean, we have the standards for traditional LCAs, but they don't really allow for an at-scale approach, really. But the advantage that we're having is that basically everything happens automatically. So the model itself is its own documentation, right? So we can basically run reports against our models, and we basically see what happened, why in the model. And because nobody basically touched anything by hand. Typically, we have a very traceable result, and we are basically, we know what's happened in the model and what happened why. The other advantage of an LCA at scale is that you basically set the boundary conditions for a certain group of products once, which means if you basically do several LCAs in a certain category, you always know that the same conditions and same boundaries are being applied, which also means that you basically, let's say, or that you basically can also streamline a lot of parts of the documentation. And yeah, you basically don't need to do this work over and over and rethink it every time. But to be frank, the verification or the review process in the documentation is currently one of the bottlenecks of an LCA at scale. We've basically found solutions, we found reviewers and partners to work that with, but as said, there is no standard in place. And the problem is basically outlined here. If you looked at this from a time perspective, right, a traditional LCA approach, you basically, it's just random numbers. So basically don't take them for granted, but you basically, let's say you take a day to set up the goal and scope. You take a month to collect the data. Then you basically take a week to model the scenario. You take another 2 weeks to write the report about it, and then you basically push it through verification, and you're done with your study. In an LCA at scale, you set up at goal and scope. It doesn't actually happen. Data collection is usually reduced to 0 because the data is basically pulled from ERP systems or similar systems automatically. Modeling happens automatically. And then the question mark is documentation and verification and how that can work and what the timeline on these ones is, because this is really the bottleneck. Right? If you think about doing a verification for one EPD taking 2 weeks, if you want to do that for 5,000, 6,000, 10,000, 15,000 products in a portfolio, you can't just multiply 15,000 by 2 weeks. That's basically, there's not enough reviewers on the planet to get done with that. And what we are currently working on is basically on ways of getting this time down to 0 as well, and finding approaches with our partners essentially to do so. And yeah, how can you do that? So generally, if we look at the LCA standards and how standardization in the LCA world works, is that we basically have the overarching ISO 1440 and 1444. That is basically valid for everything. And then we have a range of standards which makes LCAs and rules more specifically, right? So an ISO 1440 just allows you to do basically anything. It just says be transparent about how you document it. The ISO 1425 basically, let's say, establishes the EPD, and that an EPD should basically define a program operator, a product category rule, and that the product category rule basically gives guide rails on how the LCA should be performed. The EN 15804 makes that a bit more specific in grouping an EPD into several lifecycle stages and giving certain reporting requirements. And now, as we see the landscape today, most program operators that are out there and that are renowned even have broken down these PCR documents, which are kind of the guide rails for these LCAs. They've broken them down into 2 parts, a part A, which is usually applicable to all EPDs that shall be produced, and a part B, which is applicable or which only contains the rules which are applicable to a certain product category. Right? None of these standards actually, well, it gives guidance on, or it basically sets out what shall be contained in the documentation, right? But it doesn't say anything about the format of documentation. Right? So there is no formal requirement that basically, or the first thing that we need to establish is that there is no formal requirement for you to have a 150-page background report to an LCA with 15 appendixes or something like that. That is basically nice to have for a review, of course, because it basically reads through one document and he's done, but there is no formal requirement. So you could, in theory, have an ISO compliant PowerPoint presentation if you want to, or an ISO compliant Excel file. There is no requirement of having that in a Word document or a PDF file or a report as such. That is not stated in any of the standards. The other thing that I want to establish in that section is that from a business perspective, an LCA at scale is not like an LCA, a one-off study. It's rather a process. So basically, from a mindset perspective, we are much more in the realm of management standards, right? So if you look at the ISO 14001 or any other management standard, essentially they all follow this optimize, plan, act, control, and then optimize again cycle. And in our opinion, although there is no standard in place yet, LCAs at scale should be seen in the same framework. And that is why we basically propose or actually agree upon the following with our partners usually. What we do is basically we split the typical LCA documentation into three parts. And with these three parts, we actually ensure the same or more transparency than we typically have in a standard background report. The only thing that you need to do is basically you need to look at three documents in turn to basically make out the details. But essentially what we have is a background report with all the, let's say, classic goal and scope documentation, which impact categories, which data sets are being used, what's the assumptions, cutoff criteria, allocation rules, and so on and so on and so on. Then we have a second document which comes from the model itself, because the model basically knows why certain things were mapped and modeled in a certain way, which is a quality assurance report, which basically transparently documents where which data set and emission has been assigned to the model and why. And then we have the LCA results, which are then also basically detailed down to each line of the bill of materials, or basically each component of the model, giving an individual LCA result for each component. And if we basically take this data and feed it into a continuous improvement cycle, this is basically what we are aiming to do with our partners, is essentially that we have this background report, then we are able to produce EPDs, given that we always produce the quality report and the result in parallel. And after a certain period of time, we have a periodic review where we pull out the background report, the mapping, the quality assurance, and results. We see, did any errors basically go into the process, or do we have levers in the meantime of how we can basically improve the process? We basically then, if we find something, we identify the data sources, we basically do the mapping to these data sources, we basically update our documentation, and we basically go through the same cycle again. That is it. And if you basically follow that process, you have very producible results, in theory, by the click of a button. And there is really nothing to review except for basically on a regular basis to see whether there is improvement potentials that can. Good. You are muted now.
Yep, in full control of the meeting. So to wrap it up, we don't say, and that is really important to state here, we don't say that traditional LCAs don't have a big potential and that they are not necessary anymore. We think that traditional LCAs have a big place in the market. They are good when it's coming to a point where you have to handle uncertain data. So basically, if you have first studies in a certain field where everything is undefined and has to be basically, like the white areas on the map. It's also good if it's coming to create averages or representative average data. Not saying that this cannot be done at scale softwares, but just saying that this is where traditional LCA is good in. Yeah, and Also, if you do comparative assertions with a comparative assessment in the end, where you also have a panel review, where you have to, where many different scenarios are required to be shown, then a traditional LCA basically has, what's the word? No, it is basically the way to go. Let's put it that way. Yeah. Nevertheless, something that we really also want to stretch here is that the first slide that Alex showed, basically, that LCAs are perceived to have basically, just a lower, are perceived as being lower in quality, lower in transparency. That's something where we really want to show that this is actually not the case. It's just a change of mindset to a certain extent, right? On how you deal with data. You just have to somehow think a bit different, but in the end, actually LCAs at scale can get to a better accuracy than the traditional LCAs. Yeah. And obviously they are also much faster. So you will gain a lot of time when you're doing an scale up approach. Yeah. And the limitation at the moment, and maybe one of the reasons why the LCAs at scale are not perceived as trustful, let's put it that way, as traditional LCAs, is for sure that it is hard to QA like thousands of LCAs, right? As Alex indicated before, we don't have as many verifiers in the whole world to actually go there. And that's why also here the mindset has to be changed a bit into a more process-based thinking. So in our opinion, LCAs at scale sometimes deliver even more reliable results as the traditional results. And one of the main reasons is for sure that you have directly use the data to create the models. There's no manual interaction whatsoever, so you just kill that human error, basically. You still can guarantee all the complexity, but you just streamline it, and you can streamline that basically on machine base or on site base. Let's as one example, right? How do you put like the energy on each and every product, right? That's just a part of deciding what mechanisms you put in there. It has nothing to do how complex things can get. Also, the modeling time is close to zero because it happens automatically. And again, the results are very much reproducible because there is only one step between the data and the modeling, and that is the upload. The results are usually more specific because you get down to an SKU or a product. And as we said, basically what is missing is a bit this best practice regarding documentation and verification. Again, we're working with our partners on that, but this is for sure the point why sometimes things are perceived different than they actually are. Yeah. So we are now coming to the Q&A, but before that, I also want to have a short shout out to our next expert masterclass, which will be on May 6th, where we will have a masterclass about riding the EPD wave. So that will be very much about EPDs at that masterclass. And with that, we go to the Q&A. Thank you so far for listening, and we'll now go to the questions asked. Yeah, Alex, I'll read them. You just basically
chime in.
Yes. So we have one question that says, for parts of the LCA that are not visible in the bill of materials, like production, energy use, waste in production, etc., how should they be added to the LCA model? You want to answer that, or?
Yes, but the short answer is it depends. So this is why an LCA at scale is the process, and it also requires implementation from our end because, because in the end we basically need to see first of all, how significant is, for example, the site energy consumption, first of all, right? So if you're basically in a context where the significance is overall low, you can probably do with an allocation and just simply add it in by allocation some customer, that's basically one example that a lot of our customers use. Other customers have detailed process information that basically allows allocating by machine hours and machine energy consumption. So it is, and again, other customers don't use this information at all because the site impact is so, let's say, little that it basically doesn't make much sense to look into it even. So it really depends on a case by case basis. And yeah, there is different possibilities, right?
Yeah. But in general, just to say, obviously, also with an LCA at scale, you have to look at all the data. So the cutoff criteria are the same, no matter if you do an LCA at scale or a standard LCA. So obviously, you're not just integrating BOM data, but you're also looking at all the other necessary data to get to an LCA result that is has a high quality. Yeah. So we are getting the answers really fast, and it's getting a bit messy on my end. Sorry. So yeah. So I'll put in. Oh my God, that's too fast. Let me go from down. So, in which scenarios cases would the LCA at scale have less quality accuracy than the traditional LCA? That's a good one.
I think I can answer that. Ideally, not at all. The problem is you can actually only do an LCA at scale if you know the system boundaries properly, right? So you should not try to do an LCA at scale if you didn't at least, or if you don't have any experience whatsoever, and you basically didn't do, let's say, at least a one-shot traditional LCA at first, because you basically just don't know what it is, what are the relevant parameters and what is important. And then you don't know what data to search for, what to collect, essentially. So it requires some experience to get it right in terms of doing an LCA at scale, and then it should basically be as accurate as any traditional LCA. But of course, there is, in theory, it should be as accurate. But then there is also sometimes data that you can dig up manually that you can't do in an automated way. For example, logistics is a very frequent is a very frequent data point where you can basically research a lot of information tediously by hand that is just not living in the systems properly. On the other hand, let's say the benefit of adding that information, you will probably do it once, realize that the impact on the result is quite low, and you basically just as well can basically live with a scaled approach where you put an assumption or you basically put in an average in these cases where you can't basically generate the data points automatically.
Yep, so I hope that helped. Let's take the next question. In the case of IT products devices, which PCR are you using for LCAs at scale? Okay, I'll take that one, Alex. Yeah, so with MakerSite at least, we can adapt to any PCR that is on the market. So basically, if we are talking about IT products, I guess you're talking about electronics. And there are, for example, like the PP Echo Passport that has an own PCR on how to handle, the different use stages, and EPD Envirotech, EPD International has an own PCR, and MakerSite basically has no problem to use both. We can even have both available, and you decide which one you choose. So that is very much adaptable. I know that there are tools out there that only adapt to one and then to another one, but like with MakerSite, you can do any. Hope that answered the question. Then wait. Yeah. When it comes to product comparison, how would you position traditional and at-scale LCAs?
I would say at scale LCAs is not so, well, depends on what product comparison means. Now, if you basically compare products inside your own domain, so you basically optimize your products and you basically compare the current generation of your product with the next one or the previous one, then LCA at scale is a perfect tool because it basically gives you all the details that you need at all the nodes, and you basically can feed that data directly back to engineers so that they can iterate over it very quickly. If you think about comparing products in different domains like cars to aeroplanes or something like that, right? That's not something for LCA at scale. That's not a use case. Full stop.
Yeah. So another question. What if there are a lot of data gaps in your systems, for example, item weight information? How does LCA at scale approach handle them? Is it even possible to use LCA at scale with data gaps? Yeah, I take the first, or you.
Okay. Yeah,
do it, Alex.
Okay. So it depends. It depends really on where the data gaps are. So ideally, for an LCA scale, you of course need some information on the weight and on the material at least. But if that information is missing, usually not all is lost, right? So basically, often this information is missing on standard or catalog parts, and then this information can easily be gap filled, or that information is simply living in two different spots of the system, and we can usually merge different sources of data to basically complement this information. So that's why it also MakerSite goes with an implementation, and after the implementation, we basically then find strategies of basically patching up these data gaps, either by basically, filling up masses for standard components and materials for standard components such as screws and washers and discs and so on. But if we can't pass a certain quality threshold, to be honest, then there's also no way of doing an LCA at scale.
Yeah, I would also say there's a range of things that you can do, but like one example, if half of the data is still in some hardbound folders somewhere in the offices around the globe, then you'll probably have another problem anyways, right? Because then you basically have to digitalize first to put it in an extreme. I have another really interesting question. Isn't it risky to transition LCA into a process management approach because important net zero carbon decisions must be made with highly qualitative data that must remain science-based?
Do you want to take that one? I need to ponder.
Yeah, I'll take that one. Sorry, Alex. I'm trying just to formulate it in a way that makes sense. So I don't see the risk of not having science-based information in a process management approach, because just because we say we have a process management approach doesn't mean that the information does not have to be there to give it that science-based point. We're just saying that one-to-one quality assurance, as we do it now, or like verification as it is done right now in our LCA community, is a bit hard to retrieve.
I'm actually thinking the other way around. Without going to an LCA at scale, without going to a management process kind of approach, you will not be able to achieve any net zero target, right? So basically, if you want to achieve a net zero target, you basically have to monitor these targets closely, and that basically involves changing your designs, seeing whether your designs improve, talking to your suppliers, maybe getting carbon footprint information from the suppliers, and then basically combining that information in one central platform and be able to iterate over that information very quickly is something that is key to being able to manage the process at all.
Yep. We have another question. It's like actually three questions in one. I'll start with the second one. Are LCAs at scale both accurate and representative, or only accurate as the graph shows? Referring to the picture that we painted for our presentation.
They are representative of one. That's basically the simple answer to that, right? So it so it's not our goal to make a representative LCA in that regard, because basically, let's say the more representative the LCA is, the more average it is, right? If you basically take an aluminium data set of Europe, it's basically an average of all the aluminium production in Europe plus all the imports, which is essentially an average of everything. Right? And then it's representative of Europe. So ideally, we try to make them accurate and not representative. And that especially in the, let's say, in the material and composition dimension. In the time dimension, of course, we don't necessarily want to show the difference between winter and summer, but we want to basically average that out to a certain extent and make it representative of a year if we use factory data. But we want to make it specific to a certain product.
Yeah. And what do you mean by zero time for modeling? How is that possible? Yeah, I think we partly already answered the question before, where we said that usually there's always an implementation phase to an LCA at scale approach, which means that obviously you will have to spend time on the data together with the software provider. But after that, time is really down to zero. Yeah. You want to add something to that?
No.
Good. Then yeah. How flexible is the LCA model within MakerSite solution? Is the user able to autonomously and easily modify the model, e.g. to reflect new equipment or new material flows within the plant? Yeah. So
in theory, yes. In practice, that should not happen outside of basically a scenario for curiosity. So in theory, if a new material flows occurs in the plant, that should reflect in the ERP data of the plant, which means the model should actually automatically update itself. So there should not be the need to change that by user input necessarily. Of course, the user can change it, but it's actually not necessarily how it should work, right? Unless you basically want to do scenarios.
Yeah. How do you replicate the exact configuration of a product, e.g. in case of complex and modular products where the BOM changes depending on the customer choice? You wanna, or I can take it? Basically, we have customers that have exactly that. And it's just depending on if the data are also in the system like that. So if you retrieve a new BOM for every customer choice, you can basically also do an LCA for each of the BOMs. Yeah. So basically you're able to retrieve exact configurations of, as we said before, products and SKUs.
Yeah. So it essentially depends a bit on the use case and on the realm that the customer is in. So there is, let's say, customers in the heavy industries, for example, they basically have a BOM that is specific to a delivery, because basically every product is made to order, essentially. So what we then import is kind of the order, and we basically import the specific production BOM of that product as it is produced. On other customers who basically just have a configuration in the regard that there is basically just like different versions that you can choose from, and then basically you have, let's say, a few hundreds of possible combinations, but you basically don't trace every order like that in an ERP system. There is also the other way that you basically take, let's say, usually all systems have kind of 110% BOM, so a BOM with all the variations included. We take that, we calculate the results on each node of that BOM, and then we feed the results back into a configurator that the customer has. And then the customer basically does that configuration, because the configuration management we can't handle. So basically, we can't, if you basically take let's say the example of a car, right? We can't know that leather seats only go with heated seats. So that's something we do. So the configuration management we generally don't do, but we can basically calculate all configurations that are possible and give results for each individual component back, and then as soon as the customer basically can configure a component, produce a bill of materials for that configuration, he can also basically run the results.
Yeah. So how can, for example, so just saying, like, we have a lot of questions, and I'm really sorry, I don't think that we can take them all, but they will be answered later when you get an email. I think, I hope, but I think that's what happens. But we'll answer one or two more, and then we would finalize the session for today, if that is okay for everyone. So one of the last two questions that we have is basically, can the LCAs at scale be combined to create company level evaluations to simulate reduction strategies?
Yes.
You want to take that? Yes.
Yes.
It's an easy one. Yes.
Yes.
That's the good thing, right? If you have all your products in there, that means you also have all the components that you need to do your products, and that means you can basically easily do scope 1, 3.1 with that. You can even do a full scope reporting. Yeah. You want to add to that?
Not necessarily. No, there's just two ways. I mean, in our platform, you can do it because we basically both support scope 1, 2, 3, and LCA calculations. But in theory, you can basically even do that outside of MakerSite. If you don't want to do the scope 3 in MakerSite, you can essentially also just pull the results out and multiply them with sales numbers, sales figures, projections, and so on. So this is always possible.
Yep.
Question is just, do you want to do it in the platform or not? So basically, I'm just saying, even if you would do an LCA at scale outside of our platform, that's always a possibility. Yes.
Yeah. So one last question: how to integrate supplier-specific data into the LCA calculations, where mostly they provide only carbon data?
That's a difficult one. Then you can also only use the carbon data, essentially.
Yeah.
Right?
Yeah.
That's it.
Yeah. I mean, you still can go back to the average data that you retrieve, and you can still regionalize that. But if you want to do an LCA, you have to get full a bill of materials of your supplier, or a full LCA, or full at least LCA result. Yeah. And then the last question for today, so I'm really sorry if I think we couldn't do all of them, so I'm sorry for that. But the last question for today is, like, how is the use phase of a product in LCA at scale represented? Yeah. So basically, what at least we do is we have those so-called PCRs, like, that represent more or less the mechanism on how things have to be calculated after gate. So everything from gate to grave, and there you can specify any module, for example, and we have the modules represented as in the EN 15804. So basically, we're going down to A4, A5, B1 to B7, and then C1 to C4 and D. And each of those phases can be basically you can basically put in your mathematical algorithms, let's put it that way, on what should happen. For example, if you say a certain window has to be cleaned in average every, I don't know, half a year, then you could put in the water use and the detergents that you need for that over a certain period of time. And when that product category is shown up, then it will calculate that use phase every time. So basically, you can automatize use phase and end of life to the product group that you're looking at.
Yeah.
Yeah.
Generally, exactly. So basically, everything that is downstream of the factory gate is in most real-world cases. So there are some customers who have downstream data of their products, but most customers basically don't know much about the product after it leaves the factory gate. But it also means that all downstream life cycle stages are calculated based on assumptions and assumptions and basically product property based calculations, let's say. And maybe, yeah, just to add to Sophie's, we have an object in MakerSite which is called a PCR. So it's also called a product category rule, which is confusing sometimes because it's the same as a document, but it's essentially a rule object in MakerSite that allows us to define rules for downstream calculations, essentially.
Yeah, that was much better explained than I did it. Thank you. So I would now, as I said, your answers will be, your questions will be answered later in the process. For now, thank you for your attendance. I hope it was informative. Thank you for both me and Alex, and hopefully see you at our next masterclass again.
Yep.
Yeah.
Thank you. Bye-bye.
Bye. Thank you.